Hey guys, how's everything going? This is JSer, who is not good at algorithms. I've been working on something else for today, so let's continue our journey to LeetCode. Today it's about 140 word break 2. I think we have done word break. Please search on my channel for that video. We're given a non-empty strings s like this and a dictionary containing a list of non-empty words, and we need to add spaces into s so that we could construct a sentence in which word where each word is a valid dictionary word. Yeah, just to actually in word break in word break, we're only asked to return if it could be split into a sentence, right? So the return value is only a boolean, and but now we need to return all the possibilities, right? Yeah, I think the idea is the same. I think, like yes, we first put our cursor at the 0, and then we start looking for possible words in this dictionary. If, like, say we matched cat, and then we will start from here and match the rest, right? The cat, sand, and sand would match this sand, and the dog would match this dog. So the output, and when everything is matched, we could collect a result, right? Cool. Let's just do that. Just, remember that we use memoization to keep track of whether the rest of the a string could be split into sentence, split into the words. But now we need to keep rather than a boolean, we need to use an array to keep track of all the possible sentence, right? Yeah, cool. Let's do that. So obviously we will create our recursion function this walk, which will require which will have one parameter, which is the index. Cool. And then the idea is we search for words to match, right? Yeah, and let's say for let word of word dict if s slice I plus length equals word. When one word is matched, we will do what? We will walk to next one, right? But when we walk to next one, we need to, how to say, we need to pass this word towards it, right? Yeah. So actually, the previous one, in previous problem, we return a bool, right? Boolean to say if it is could be done or not. So now we need to return what? Return an array of return how to say, return string array, right? Yeah. So now let's get here. It is const next matches. We get the next one. So let's suppose that with this walk, well, we'll at least words return an empty array. And okay, we need to matches, right? Create matches for this specific index, and then finally we will return these matches. There will be a for loop of all the possible words. So for these matches, there will be all kinds of possibilities. We shouldn't break if we find one, right? In previous one, we find someone, we could just break, but now we need to push it to the matches, right? So for let next like a word, no, sentence of next matches. We need to matches push word plus sentence, right? Yeah, and yeah, we find some word and we find the next matches from this one, like cats. We find the matches from here, and then for each match, we need to add this word, so it's a new match, right? Yeah, cool. And return matches. So this is done, right? We just return walk 0. Yeah, but this is a ending condition, and the memoization we haven't done. So if I would be bigger than length, would be if it overflows, then we return what? We return empty. Empty means there's are no matches. Yeah, we could do that. We return empty. But there's a problem. If we return empty, we need to enable the last words, right? Because for that last word, if you find it, next match will be empty, so this will be empty. Actually, I'll say next index would be like this, right? And let's say if next index is overflow, then we would say this is the last word, right? So it would be very simple. We just push the word in it. If it is not last word, then we define next matches and push them one by one. And yeah, this is the result actually. But we need to use a memoization. We say the cache, new set. If cache has I, we return cache get I. And here we set it, cache set I matches. Cool. Let's run the result. Let's try. Oh, cache set is not a function. Cache. Oh, God, it's not map. It's at. It's not set. It should be map. Cool. Looks like we're accepted. Yeah, we accepted, and like 60% fast. Not bad. And let's try to analyze the time and space complexity. For time, actually, for each word, right? So the word, you see, we are using a recursion. This will loop through all the these dictionary would be, I think, no duplicate. So the worst case would be, as we analyzed before, is something like this, and like this, right? So the time would be And yeah, for each position, let's try to analyze it again. We use memoization. Ti equals to what? Equals this will be these kind of possibilities. So if we choose this one, it would be Ti minus 1 plus this, right? This will be also possible, and this will be I minus 2 plus dot 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 until we met T1. T1 would be we check over n times, right? And actually, this will be n, Tn minus 1. This will actually be cached. T1 will be calculated one time, and T2 will be calculated how many times? Give me a second. Ti minus 1. And for that, we will go to, so when we calculated these ones, actually, these are all get. So actually, this will be 2 Ti like this, right? Actually, this won't be extra check in this one. This will all be cached. Let's draw a tree to make it simpler. Like when we walk to 0, we will need to check 1. Also, we need to check 2. Also, we need to check 3, right? But check 1, we need to check 2 and 3. So once 1 is checked, when we check 2, they're already there. So it's this. So the time complexity would be like this, right? Space we use a map to keep track to cache the result at specific index. So there will be how many roots in one specific, right? In one tree. Well, for the last one, it would be 1. For the for 1 here, it would be, for last one, it will be only 1. If there's a second one, it will be 1 plus 2. I'll say how many are there. Let's also write a formula. Si equals Si minus 1 with 1 possibility plus T S minus 2 plus S1, right? This will be if choose 1, this kind of possibility, right? And the at plus this one, right? Here it would be, it's the space complexity. But here, yeah, we match this and get this kind of space, extra strings, right? Yeah, so this is true. There is no cache or something. We use this cache. So all the possibility, this would be what? This would be 2 this would be 2 si minus 2 plus si3 plus s1. And then it would be, this will be this, right? So 2 times 2 si minus 3 plus s1. And then this would be, yeah, right? So at last this would be 2 to the power of I minus 1, right? 2 s1. You see, when this becomes 1, this should be I minus 1. So it is I minus 2. So what kind of space needs for one element? Well, of course, there's only one possibility. So this would be still linear, 2 to the power of n. This is also for space complexity. Well, we could just think it like more simpler, that every word could be in it or not in it, right? So yeah, 2 to the power of n. Cool. That's all for this problem. Hope it helps. See you next time. Bye bye.